All right, so let's try this again. So it says the length and the width of the rectangle is or are 15.5 centimeters and 10 centimeters respectively. So this is the length and this is the width. Okay. So what I want to do is I'm going to over here to the side. I'm just going to sketch a little bit of a box, and I'm going to say that the length is 15.5 centimeters and the width is 10 centimeters. Okay, so we can get an idea. Now, when we're talking about precision and accuracy, precision is saying, all right, when I measure 15, and we're going to think of like a ruler, right? A perfectly drawn ruler. Actually, let me do a little bit better job. Okay. Think of a ruler that looks like this. So on the ruler, there is a mark here for 15. And way over here, there's a mark for 16. And right there in the middle is 15.5. But when I measure my rectangle, I could be a little bit, I don't know for sure. I could be a little bit before 15.5 or the measurement could be a little bit after. So the precision level is half of whatever significance that you have. So what I'm trying to say is because we're going to one decimal place here, then I'm going to have to consider, I got to remember where my screen was. Yeah, I have to consider an error factor. So for my minimum length, the error factor is I'm going to subtract 0.05. So I'm going to take a half of whatever half of this is. And what that's saying is at the minimum, my measurement might be way over here. That is, and think of this as me zooming really, really, really far in. So this would be 15.045, I think, right? Well, we'll do the math on that in a second. I think that's 4.5. 4.5. And then they're saying at a minimum, my measurement might go this far past. So that means I'm going to add 0.05. Okay. So then that gives me somewhere over here, it could be as high as, and this is just an approximation, 5.5. Right? And I know it's a little squiggly and you can't see it, but basically what I'm saying is my minimum value based on precision could be as small as 15.45 and as big as 15.55. And so what we're doing is we're plus or minusing 0.05. And we would do the same thing for the width. The width is 10 minus 0.05. Or we're adding the maximum width could be 10 plus 0.05. And so that gives me the width could be anywhere between 9.5 and 10.5. And so when we continue on this problem, the minimum, we'll change the colors here. The minimum area is the minimum length times the minimum width. Well, we said that the minimum length was 15.45 and that the minimum width was 9.5. Now, you guys should get out your handy-dandy calculators. And when I put that on my handy-dandy calculator, Let me make this a little bigger so you guys can see what I'm doing. I'm just going to say 15.45 times 9.5, and we'll get 146.75. Okay? And so if we were to round to the nearest one, and I'll talk about why we're choosing to round to the nearest one in a second, that actually ends up becoming 147. The reason we're rounding to the nearest one is that my measurement here had my precision was to the 10th. So because I'm uncertain of this measurement, I have to go to the ones. So we're always going to round to one level higher. I'm trying to use words that kids would use. So now let's do swag. No, we're not going to say that. It's not appropriate. When I call your parents and tell them how you're disrupting class while I'm teaching, I'm going to show them this video, and then they'll hear your voice, and then they're going to have a nice long conversation with you. Focus on the math. Now, to find the maximum value or the maximum area, we're going to take the maximum length. What's the maximum length? It's this number right here. That's going to be 15.55 times the maximum width. What's the maximum width? 10.5. Oh, now you want to be quiet. Again, plug this into our handy dandy calculator. Oh, I hate that because now I got to erase it. Handy dandy calculator. Make sure I click on the thing. Make sure I extend this up. There we go. So I'm going to say 15.55 times 10.5. Well, bam with the bacon sizzle. And I get 163.275. So when I go to round this to the nearest one, so the one spot has a 3 in it. So I have to decide if I'm going to round up to 4 or round down to 3. So I look at the number to the right of it. That number is 2. 2 is less than 4. So I round down. So what do I put here, kids? 163 centimeters. So our minimum area could be as small as 147 centimeters. Our maximum area could be as large as 163. Does that make sense?
Yeah.
Okay. So if we go back to this original drawing, essentially what we're doing is we are taking the maximum area for this, and it might be just a little bit bigger based on us having an error in our measurements. And then we're also saying, you know, what else is also possible, although highly unlikely, it could be possible that we made a mistake and maybe we overmeasured, and so maybe there's a little square or a little rectangle on the inside. And so we're measuring those two things. Let me pull this out so you can see what we're talking about. They're saying that it is possible that I have a rectangle, and the very smallest that rectangle could be, would be 15.45, and the width could be 9.5. So that's the little bit smaller one. Or I have a rectangle that I made an error in my measurement, and it could be 15.55 by 10.5. And so the area for this one would be 163, and the area for this one would be 147. And then there's an area for this one too. If you do the math on that, The math on this would just be 155, which is right in the middle of those two numbers. Right? Multiplying the length times the width, right? And I probably should have said that, right? Remember that the area of a rectangle is just the length times the width. Okay? Any questions on that?